Welcome to this session of the Highway Capacity Analysis video series. We have been going through several different points and trying to fill in some gaps in these procedures in the analysis using the Highway Capacity Manual implemented as the Highway Capacity software. And this last one is talking about optimizing signal timing. The Highway Capacity Manual 6th edition is backed by research and peer review with millions of dollars of federal money creating the research and the procedures from that research with peer review out of a couple of hundred subcommittee members, experts in the field to make this the most defendable set of procedures. And that's why you would like to have something like that for optimizing your timing. Some of the things that are done in the HCM and HCS are not done in other tools that optimize signal timing. Multiple paired analysis, as you may have heard in one of the other videos, is absolutely necessary for congested conditions at a signalized intersection to collect the extra delay that's caused by unmet demand from period to period. The phase duration model estimates the average phase length for actuated movements, and you've got several cycles in a 15-minute analysis period. You have to know what those movements do and what the average is over those multiple cycles, and that's not always easily obtained. Saturation flow rate, all the many details and saturation flow adjustments are available within the HCS interface, which allows you much more control and get down to the very finest details if need be to get the right answer, which generates capacity. The flow profile is a model from Transit 7F that models the platoon running from the upstream signal to the downstream signal to generate proportion riding on green as an indication of how well that segment or those two signals are coordinated throughout multiple signals in an arterial. And that flow profile process accounts for the fact that access points for driveways and unsignalized side streets that influence the effect of those platoons, slowing them down and breaking them up, making it very much more difficult to arrive on the green. And that is modeled in this procedure, and most of the time it's not modeled, and that makes it look a lot better than it really will in the real world. These procedures also include interchanges, which are modeled slightly differently than other intersections along the arterial, covering a diamond interchange, a single point urban design, a diverging diamond interchange, and 6 different flavors or designs of partial cloverleafs that can be part of the arterial that you're modeling. This also includes, beyond the diverging diamond interchange, the displaced left turn and restricted crossing U-turn that could also be on an arterial with signalized intersections that would be part of your coordinated process. The optimization dashboard looks like this, and it shows that you can optimize cycle lengths, splits, and offsets between intersections for several different objective functions. Overall delay if you've got 1 or 2 signals, arterial delay or arterial stops, or even travel time if you have multiple signals, or level of service if that's what you're after across multiple segments. You can also give added weight to the forward direction. Let's say it's an AM peak and you have 80% of the traffic going in one direction. You can give it 80% of the priority. You can even optimize phasing sequence, but typically that's not that's done by for other reasons. So again, this is the 5th one that we've done, but if you missed any of the other 4, we talk a little bit about why use the HCM and HCS as opposed to another tool, how important it is to know the details of the procedure before you become the analyst, and training is a good idea. I mentioned multiple period analysis being mandatory for congested signals, and also the access point influence on platoons between signals. So please take a look at these others if you haven't already. There's contact information for me. Please let me know if you think I can ever help in the future. Appreciate you tuning in. Thank you.